something momentous has happened. While we have been going about our daily lives, the world turned. Climate change is no longer a distant fear. It has now become a clear and current threat. Things that used to happen in geological time spans are now unraveling in our lifetimes. We are the pivot generation. Before us, normality. After us, potential chaos. It falls to us to apply the brakes that will prevent climate change becoming a runaway juggernaut that no one can stop. The future of human civilization will be what we make it. Global warming is a roadmap for what is happening to the planet and what we can do to stop it. Which of us hasn't thought at some point, what difference can I make? What difference does just one country make to a truly global problem? I've spent over 20 years as a journalist reporting on climate change, and I think that we have lost sight of the big picture. Instead of debating who should do what we really need to do is look at what is unfolding around the planet and see what it will mean for us at home. Because climate change is here now, and things happening a long way away are already reshaping our lives. Greenland, 6 times the size of Germany. Its vast, 3-kilometre thick ice sheet is so heavy it has literally flattened mountains. It is now a matter of when and not if much of it melts, and when it does, everything changes. Greenland is much greener than you expect. 1,000 years ago, the name was a lie, concocted to encourage more Viking settlers. But it has become more and more true with each passing year. Ellen Fredrickson has lived all her life in southern Greenland. 40 years ago, isolated farming settlements were all connected to each other for 7 months of the year by sea ice.
From where to where is frozen? All the way from there?
Yes, all the way.
Can you get down to Narsaq?
Some years we can do that back in past.
But the fjord hasn't frozen over at all for 7 of the last 8 years. And when it should be 0 degrees and snowing, it's 9 degrees and raining. Ellen is a teacher in the small settlement of Kasiarsuk, just 12 pupils in the school. The settlement is only 100 years old, but the rate of warming in the Arctic is so fast, Ellen is doubtful about the next 100 years.
The weather started to change extremely in 2006. We had no rain in 3 months, where all the grass began to die. And some places the harvest reduced up to 80%. Some people are saying that when the climate is getting warmer, it will be better for farmers. The winter will be shorter, but we don't experience that. More like that the weather is getting more and more extreme. Drought and but in the 3 years there were not so much snow. Farm life in South Greenland is very special, and our culture is very different from the rest of Greenland. I'm thinking of how it will go when my school students, when they are adults, because farming here is a family business where they take over. If it gets more extreme, then we have a lot of challenge to continue our farming life.
Greenland's ice sheet is the accumulation of many millions of years of snowfall. Now, though, that process is in reverse. The ice is retreating. Rain, sun, and warm seas are driving it back.
As the climate warms, the snow cover on the ice sheet is retreating to higher elevations. It's also being melted off earlier in the season and not returning until later of the season.
Professor Jason Box has spent much of his career trying to find out why the Greenland ice sheet is melting 5 times faster than 20 years ago.
The Greenland ice sheet is an interesting relic of the last ice age. And here today, Greenland is quite fragile as we go into the 21st century of warming.
Jason's work shows that melting is now significantly faster than has been forecast by the world's climate scientists. His fieldwork on the disintegrating glaciers offers detail that computer models can't catch.
I've been working all around the Greenland periphery in recent years, and there has been, in some areas, 1,000 feet of thinning. At our ice monitoring sites, we get a lowering of 2, 3, 4 meters per year. But on the neighboring tidewater glacier areas that are moving much faster, that's why we don't put our equipment there, you get annual thinning of 10, even 20 meters.
This is dark, dirty, and quite foreboding. Yeah, it's the color of concrete, and this is the bare ice. So up higher on the ice sheet, you get the bright snow, but as climate warms, the snow line is creeping upward. And do you have an emotional reaction to that, or just a scientific one? Usually I try to stay objective about it, but sometimes it hits me.
Dark ice glaciers, like touching down on another planet. They're dark because the falling snow has captured carbon pollution from around the world. White ice would normally reflect back 70% of the sun's radiation. Dark ice glaciers now absorb 70% of that heat, further accelerating the rate of melting.
It really does feel very otherworldly, doesn't it?
Welcome to the moon.
Yeah.
Most of the darkness you see is actually biological. At this location, the average melt is more than 6.5 meters.
Every single year.
Yeah. This automatic weather station is recording a lot of meteorological variables, wind speed, direction, temperature.
It's not just sun. Intense rainy thunderstorms are melting the ice too. Rain works its way down through the ice, fracturing the glaciers, lubricating and accelerating their passage out to sea. The rate at which they now flow has doubled in recent years. And there's more. warmer seas are melting the mouths of glaciers from underneath, causing them to calve ever faster. The churn in the water, or jacuzzi effect, as the ice breaks off, further raises the temperatures of the water. If the Greenland ice sheet passes its tipping point, the moment of irreversible decline, it would ultimately add 7 meters to the levels of the world's oceans.
I wanted to show you this mountain over here. It's effectively erupting out of the ice as the ice is melting downward, and it's just getting taller as the ice around it's melting.
So the landscape is literally changing year on year. I mean, are there times when you don't recognize it?
Well, especially over here, the ice is retreating so quickly on land, we realize we're going to have to reposition all of this equipment in the next 10 years or so. We're losing this dead ice here next to this tidewater glacier.
When you say dead ice, do you mean ice was effectively kind of 1 foot in the grave?
Yeah, some have called it zombie ice. Well, we can see in the last 20 years of satellite pictures that this area is kind of doomed. I call it a disaster in slow motion.
Wow.
This is one of about 200 tidewater glaciers from the Greenland ice sheet that are draining about 500 billion tons of ice per year. This one here is moving about 2.5 kilometers per year. They doubled in speed between the years 2000, 2005, and the cause of that turns out ocean warming, warm currents were destabilizing these glaciers, making them thin and then lose stability from the bed, and then they just disintegrate. Ocean warming is one of the key concerns in addition to the atmospheric warming. So there's this strange competition for which produces more ice loss. Is it ocean warming or atmospheric warming?
But the point is that the glaciers are getting buffeted from all sides. Does that suggest to you that the officially agreed scientific figure between 50 centimetres and a metre of sea level rise by the end of the century is, if anything, a very conservative figure?
Absolutely, it's conservative. The physical expressions for the effects of rain, the effects of dark ice, the effects of forced ocean convection at the tidewater glacier fronts, they're simply lacking in today's models. Basically, it's a 1 in 20 chance of high impact sea level rise, 2 meters by the end of century. 1 in 20 chance, 5% chance, right? And a useful analogy is if you're standing by a busy road and there's a 1 in 20 chance that you'll get run over by a car if you cross that road, do you cross the road? Of course not. It's low probability, but it's high impact.
If that was to happen by the end of the century, that's the homes of 630 million people around the globe that would be lost. That's unimaginable.
And it's not just coastal areas, it's the inland economic and physical ripple effects of forced relocation of people that will destabilize political systems and economies.
This is nothing less than a credible warning from the future, a signal about how the unraveling of human civilization could begin. But it is a warning, one of many possible scenarios. What actually happens is still in our gift to them. If climate change meant only that the oceans would rise as Greenland melts, perhaps we could adapt. But it has another nasty surprise in store. The Gulf Stream system has for 3 million years made Western Europe temperate and its seasons largely predictable. But Greenland's melting ice sheet has thrown a spanner into the conveyor belt of the ocean's currents. Normally warm salty water at the equator moves north, cools down, then falls from the surface and returns to the equator. But now billions of tons of fresh water pouring off the Greenland glacier is slowing that cycle down to potentially disastrous effect.
These overturning circulations, they fundamentally set Earth's climate, they fundamentally set where we should grow food, where we should have cities. Disrupting these overturning circulations changes our Earth's climate at a profound scale. It resets where we do stuff. It means re-engineering where we live, where we find our water, where we grow our food. This is not something you can do in a hurry.
All that fresh water pouring off Greenland into the circulating salt water has an impact not unlike throwing sand into a finely oiled machine.
That amount of fresh water from Greenland is just remarkable. What happens when that flows into the ocean is it dilutes the water there. Losing salt means it loses density. Losing density means the overturning slows down and eventually shuts down. So it's a real threat to the North Atlantic overturning circulation.
The consequences for Europe and North America would be chaotic.
If we slow it down, if we shut it down, it's such a fundamental part of the climate system, you disrupt it. You disrupt the storm tracks, you change the weather patterns, and you change the way the oceans interact with the climate system in profound and costly ways. This term, a new normal, I find it really difficult because there is no new normal. The pace of change is like that, it's not like this. And actually the pace of change is only going to get worse.
Things won't just stay this bad. There will be no new normal as the ocean circulations slow down. The only certainty will be a permanent state of flux.
What we're doing at the moment is a sledgehammer-like clubbing of the planet. The chances of overturning circulation collapses in the next decade or two, that's a big debate. It's like we're talking about 20% chance. Some scientists say 100%, some will say 7%. Those numbers, when you think about relocating cities, shouldn't matter. These are circulations that control our Earth's climate and that we need to have remain stable, otherwise we're going to start doing a lot to support life on Earth.
Life on Earth above water will be thrown into turmoil as ocean circulations decline. But underwater, it will be a little like turning off the oxygen pump in an aquarium. Stagnation leading to ecosystem collapse. More heat bringing more energy, more storms, and more hurricanes.
I can get through a day fine looking at these scientific diagrams because I nerd out on them. But I get home at night and I see the kids, and they're going to have kids, and I'm deeply saddened by what I'm seeing. This is a great planet. I won't be around to see my projections and how they play out, but bloody hell, everybody else will be.
The Atlantic's overturning circulation is now at its weakest in more than 1,000 years, and as it gets weaker, it could eventually reach a critical threshold where it will shut down, as if grinding to a halt under its own weight. This is not science fiction. It has happened in the past. Scientists think of this moment as another planetary tipping point, a point of no return, after which all weather systems in the North Atlantic will be totally transformed and chaotic. We are against the clock, only we don't know how much time is left before that tipping point, or even if the clock has already stopped. One immediate consequence of more heat in the oceans is more violent tropical cyclones. These natural disasters are no longer natural. Now they are partly man-made, and made many more times likely by increased temperature and moisture in the atmosphere. Temperature we've put there. The results are felt acutely on the continent of Africa. Feeding the 1.2 billion people in the sub-Saharan region in the next 30 years will be one of humankind's stiffest challenges.
Severe weather warning remains in place for Cyclone Freddy over the weekend. That's when we're expecting torrential rains, heavy flash flooding,
and left tens of thousands displaced in Malawi.
Some villages were completely wiped out. So it's a disaster of untold proportion.
Malawi is one of the African continent's smaller countries. 20 million people live in an area smaller than New Mexico. Most are barely able to feed themselves in the good years, and now climate change has made those years further apart. The crisis is accelerating here. Drought periods extending, storm damage intensifying. Often one part is baking, while at the same time another is being swept away.
In the past 5 years, we have experienced a lot of floods induced by these cyclones or tropical storms. And this year we have already experienced another cyclone. When do we have time to recover from that? Our economy is already worse, and those are issues that we are experiencing as a nation.
In February and March of 2023, Cyclone Freddy hit East Africa as a Category 3 cyclone. 2 weeks later, it hit again as a Category 5. Then it was further upgraded to very intense. That's how climate scientists say off the scale. The energy in this one storm was the equivalent of an entire hurricane season in the North Atlantic. In Malawi's second city, Blantyre, weeks and weeks of rain resulted in a mudslide into the heavily populated valley below.
It was around 1 a.m. where we heard a sound, just like a truck, just like a train or earthquake, something like that. And then I woke up my family and we started going higher, running away from the house. But then I started hearing cries from the people inside their houses. We couldn't reach them because it was dark. There were flashes of water. They were gushing. We couldn't see what is happening. And the mud and the water was actually hot.
Chisaundi chimene ndinamva chionena kuti ndinamva kugunda ngati nthaka ikugunda kwambiri kena kuno nadziwa kuti nyumba yanga ija katseka nzirani yagwa yonse yatha. Mene madziwa kuona kuti chikuchitika ndi chani ndabula kuti ndili pansi pa madoti nyumba ija ndivindikira matope ativindikira ananga inamuphiza ndizi nyumba amene nalipo nyumba inali yolimba zipika zija sizimanyenyeka zidoti zija zimankhanga kuti zikungusanjikizana nkona ndinaliphera kumpulumutsa mwana nthawi imene ataba utalifukula pamene paja nthawi imene matali alifukule mwana uti anapeza kuti ndikufa. Mwana amene anamwalirayo zina lake anali Timothy Ngwira anali standard 4 panopo anali chiyembekezo chonena kuti mwana wangayo akalowa standard 5 manthu amene asekera akaseguliramo.
Timothy's was one of hundreds of deaths in a cyclone made more violent by climate change. If warming is not reduced, by the end of the century, 3.4 million people a year could die as a direct result of climate events.
It was just a bang, and within 5 minutes, the muds were down, the rocks were down, and everything. And within 5 minutes, everything was done.
But all happened so quickly, there was no chance to escape?
No, 5 minutes, just 5 minutes. But you can see even the rocks that are here, they are so huge you can't even move them. So if a house or an individual is trapped underneath, there is limited support.
And are many people still missing?
Yes, we have over 500 people who, because of the time that has passed, it's been declared that they're just dead. As we are walking, we might be actually maybe walking over some houses, and people who are missing are still down there. So it is a mass grave.
A second disaster looms. When the rains come again, all of this ground could loosen and become another mudslide. Cyclone behaviour is changing. The number making landfall and penetrating further inland is on the rise. And the amount of rain that they can hold will also increase in a warming atmosphere.
You're a landlocked country. Why would you expect a cyclone out in the Indian Ocean to have the impact that it did hundreds of miles inland?
Well, if you look at the trend over the past 3-5 years, Malawi has been experiencing cyclones. And you can see that the severity of each one is getting worse as the years are going by. So going forward, we should expect more frequent and more devastating cyclones hitting us, despite the fact that we're a landlocked country.
Almost 700,000 Malawians lost their homes in Cyclone Freddy. As they waited on rooftops for the waters to recede, some were preyed upon by crocodiles. And when the waters did go down, the crops and livestock of 2 million farmers had been wiped out. Lake Chilwa flooded so much its shores have moved 800 metres, thousands of hectares of farmland gone. Cyclone Freddy was not an isolated event. Cyclone Gombe and Cyclone Anna struck the year before, like being hit again and again before you've recovered from the last knockout blow.
That is what climate change is. That is the change that has been induced by all these greenhouse gas emissions. Children are not supposed to go to school in an environment that is not safe. We had the schools closed for almost a term. People lost their property. People lost their homes. If we talk about the mental health of the young people, of the people that have been affected by this, that is the issue that we are going through with this climate change.
Whether it's due to rising seas, storm devastation, or unlivable heat, by 2070, scientists' worst-case projection is that almost 1/5 of the planet will be uninhabitable, the homes of 3 billion people.
The developed world is no longer immune to events occurring great distances away. Supply chains, energy and grocery bills, housing markets, whole economies get buffeted by the shock waves emanating from conflict and natural disaster on the other side of the world. How this will not be the most unmanageable period of human history is unclear.
Indigenous peoples are quicker to feel the effects of climate change than most. North of the Arctic Circle, a number of different communities live pastoral lives in sympathy with the cycle of the seasons. But now warming is melting sea ice, which disrupts local weather systems. The result is this nomadic society on the Yamal Peninsula in Siberia have had to watch thousands of their reindeer starve to death in recent years. The Sami people of northern Scandinavia are looking at a similar fate as climate impacts hugely on the reindeer's ability to forage and feed.
We are a people within 4 different nations. So you have the north of Norway, you have the north of Sweden, you have the north of Finland, and the Kola Peninsula in Russia. So that is what we call Sápmi, or the Sami land. And within there, in most places, we do conduct reindeer herding. Climate change has created a lot of uncertainty. We're used to having harsh winters, but what we're seeing today is that there's no regularity. So every winter might be completely different. What we're seeing is that we have warmer periods during autumn with rain, with heavy rainfall, that goes over to a colder period with snow. And this creates layers of ice on the lichen. And the reindeer feeds predominantly on lichen during wintertime. Reindeer can smell lichen under 80 centimeters of snow. But when you have icing on it, it doesn't create the same kind of smell. And even if they were to smell it, if they dig down, they can't claw through the ice. It takes them too much effort, too much energy that they have to save during winter. So then they will venture off to try to find better grazings, or they will starve to death.
Across the Arctic, reindeer and caribou populations have fallen by 2.5 million in the last 20 years, half the world's population. There are many reasons, but chief among them is the loss of foraging due to climate change.
With what's going on with the climate, it has really taken a real good toll on it. It is looking dark, but I still have to have hope. You still have to think that the future will be better, and it will be better for future generations. My roots go so deep in this landscape. It goes so deep, we have been here for forever.
We could think of indigenous peoples as uniquely vulnerable, or we could think of them as early warning signals. The indigenous communities of the Arctic are canaries in the coal mine, whole civilizations on the brink of losing their way of life, their culture and their livelihoods due to climate change. Today, it's them. Tomorrow, it will be us. We are surrounded by tipping points, planet changers, points of no return that we could cross at any time in the next 10 years, like the one hidden underground in the Arctic. A trapped and long dormant deposit of carbon, twice as much as is already in the atmosphere. Under our feet, out of sight and mind, we are unaware that the more we warm the planet, the more we are rousing it to deadly effect.
Permafrost is permanently frozen soil. And this permanently frozen soil contains a massive amount of carbon. Approximately 12% of the land area of our planet is permafrost soils.
Permafrost is ice-like, peaty soils. In its frozen state, it lies dormant and harmless, but global warming is thawing it, poking a sleeping bear of carbon and methane. A vast belt around the top of the world of potential warming gases so huge it's calculated in thousands of billions of tons. And the more of it that is released, the more warming it will do, the more that will be released.
So going from here to the east, we would go to Finland, then we would get to Russia, Siberia, Canada, Alaska, Greenland, and come around to Norway, and then we'd be right back here.
So that entire landscape, the soil, the peat under our feet is frozen in permafrost.
Yeah, now in the mountains here we have permafrost, but it's a different type of soil. The peatlands are primarily in these areas where you see these mires in the valley down here.
Keith Larson is an ecologist. He's devoted the last decade to understanding how climate change is altering the vast wilderness of the subarctic.
We're 200 kilometers north in the Arctic Circle, close to a village called Abisko, where there's been a scientific research station since 1913, so kind of almost spanning most of the modern climate change.
Scientists here have accumulated over a century's worth of data that sheds light on how fast the permafrost is releasing carbon dioxide and methane. The ground is now sinking where the ice is thawing.
We're actually in a permafrost mire where the soil below our ground is peat. But some of that peat is permanently frozen, or it used to be permanently frozen. And I'm elevated right here, and that's because not only is there permafrost deep down in that peat soil, but there's ice. And that ice essentially lifts the soil.
Okay.
So where you're standing, the ice is melting, as well as the permafrost thawing. If we go back in time, everything was elevated here. Then gradually, as we warmed our planet, it became this cotton grass type habitat. It's quite spongy.
You can hear it squelch under you as well.
Yeah, exactly.
The release of gases to the atmosphere is now so pronounced you can see it with the naked eye.
This is a thaw pond. The permafrost is quite visual here because, right now what we're seeing are these bubbles coming up right now. And even when we don't disturb it, every once in a while, you just get this little burp of gases coming up.
Releasing the locked up gases from just the top 3 meters of permafrost would be the equivalent of burning every forest on the planet 3 times over.
It's not a matter of if, it is already thawing. And the bad news is that when this permafrost thaws, some of that carbon winds up in the atmosphere as either carbon dioxide or even worse as methane, which is about 25 times as potent as carbon dioxide.
And so how deep does the permafrost go here, Keith?
Here it's tens of meters thick. But if you go to the east, for example, into Siberia, some of that permafrost is as much as 1,400 meters thick. We are experiencing climate change in real time here, like many places of the world. When I first came here in 2013, I was surprised that it would rain in October, November, December. But in the last 2 years, it's not only raining in October, November, December, but January, February, March, April, and May. So we're now getting rain every month of the year. But this is the Arctic. This is supposed to be a place with cold winters. The cold winters have disappeared.
Jessica Gilman-Ernokovich is an environmental scientist who studies the rate of thawing of the permafrost. Taking core samples across the landscape year after year allows her to measure how fast it is releasing warming gases.
A lot of the time when we're thinking about permafrost and the global climate, we are talking about permafrost that's been around for hundreds of years to thousands of years, to sometimes even millions of years.
Core samples from just a metre underfoot reveal how each year a little more of the permafrost turns from an inert frozen mass to a living and breathing organic soil.
Okay, that's beautiful.
Each core sample is like a thermometer reading of the soil, charting from year to year how much the ice is melting.
Okay, so I kind of suspected this was true, but we have this frozen active layer still here. So from here to here, we've lost in about 20 years.
So in 60 years, this much has thawed and has released, Lord alone knows how much carbon in this area across this entire landscape.
This entire landscape, this entire region, and really the globe.
Just like the Greenland ice sheet melt, much of what Jessica is monitoring on the Swedish tundra isn't yet included in the official scientific account of our climate's change. And once again, it is also moving faster than the official forecast.
All right, so here's a 10 to 15. I would say the fact that the public debate is so far behind scientific knowledge is one of the hardest things for me to understand as a scientist and as a human being also trying to live on this planet. It can be frustrating that we aren't moving forward with our knowledge.
We're kind of sweeping something fairly significant under the rug.
By not accounting for these permafrost habitats, we may actually be completely offsetting everything that we say we're doing, simply by not taking a proper account.
Every tiny fraction of a degree of increased warming does more to poke the sleeping permafrost bare. The good news is that scientists think that stopping those emissions would over time stop the thaw. The bad news is the only fix is to stop emissions. And this is why it's not just the big emitters that matter. Small countries are important too. Every ton of carbon unlocks even more carbon and even more warming. All the small countries that might think that their contribution is insignificant account for a third of all the world's emissions. I've been reporting on global warming for over 20 years. You'd think that I would have heard all of this, but I'm alarmed by what I've learned recently. Everything is now moving so much faster than forecast, accelerating and intensifying at a rate that will make climate breakdown the story of the rest of our lives. The next 200 years will see Earth transformed beyond recognition. How much is still in our hands. I have also heard and seen something else that's important. The depth of the love that we feel for the natural world, and even more so for our children. We now know exactly what this crisis will do to their futures. We are surrounded, though, by messages that tell us we can continue business as usual. What these scientists, what the planet itself is telling us is, we can't. We have to stop ignoring what is coming and then be the heroes we want our children to see. Their future will be what we choose to make it. The only time left to make that choice is now. In episode 2, as the world changes, how will we change with it? What should we be doing now to stay ahead of the climate change that is coming? Will it be rings of concrete and steel or mud and grass? How do we choose the places we are not going to defend? How do we defend what we hold dear? The developing country that the developed West has many tricks to learn from, and managing the landscape to manage the threats of fire and flood. Adapting to a new kind of life on Earth in Programme 2 of 3.